Okay, good afternoon, everyone. Welcome to the Developing for Mobile and Web on AWS. My name is Amit Patel. I'm the General Manager for Mobile at AWS. In this session, we're going to be talking about the full breadth of products and services that AWS offers for mobile and web developers. And we have over 50 sessions throughout this week so that you can dive into any of these topics in more detail. So with that, I'm going to kick off with a few numbers just to sort of lay out what's going on in the industry and what we're seeing with our customers. So app downloads continue to grow. There's forecasts out there that show that it's going to grow by 45%. Year over year, about 8% a year for the next 5 years. Also from customers, we're hearing that both native and web development is important. Over 80% of our enterprise customers tell us that they're going to do both native and web development. And that second piece about web development is also driving a lot of adoption in JavaScript, and I think many of you will be aware that JavaScript popularity continues to increase. Over 70% of developers are using JavaScript for production apps. And then the last one is quite interesting. This has been emerging over the last couple of years. We've seen since 2016, the adoption of GraphQL has increased by 4x. Just a show of hands, how many people are familiar with GraphQL? Okay. Pretty good, more than 20%, so that's good. We're going to be talking quite a lot about GraphQL in this session. In addition to those numbers, there have been things that developers are asking for that kind of fall into kind of four main buckets. So first of all, as I said already, developers want a choice of native and web. For the JavaScript developers, they also want a choice of frameworks like React, React Native, Angular, Ionic, and Vue. And it's not one size fits all when it comes to how people are building their apps. The second piece is around the cloud enablement of your apps. And in this area, developers want an easy way of creating, configuring, provisioning back-end services for their apps without having to be experts on every single cloud service. And this is an area where we've kind of been working to deliver an experienced back-end team on your terminal with our products. The third area is scalable and secure back-end for the app. And this is primarily around how data is stored in the cloud, how it's managed, how it's synchronized, and so on. And then finally, some tooling for CI/CD, for testing and deploying and hosting web apps is also a key ask from developers. So to address these four areas, we started out on this journey a couple of years ago, and then 12 months ago, around this time, 12 months ago, we launched a couple of new products. The first one was AWS Amplify. AWS Amplify is an open source framework. When we launched it 12 months ago, it was JavaScript only, and you'll see we've added a lot more since then. And the other service we launched was AWS AppSync. AWS AppSync provides developers with a managed serverless backend for their apps, for their app data. And since we launched those two things 12 months ago, we've continued to add features to both of them. First, we launched support for a number of frameworks, including Vue, Angular, and Ionic. Then we've launched, in August this year, a CLI toolchain and UI components for Amplify so that you can do drop-in UIs in your apps. For AppSync, we've launched a whole number of features. I actually had 2 slides of them, and I kind of condensed it down to a couple of things here. So we have GraphQL API Builder, we have HTTP data sources, and GraphQL scalar types as well, and a huge number of other features. And then finally, a month or so ago, we launched a new support for iOS and Android SDKs and specifically around authentication for iOS and Android native developers. Native developers have been asking for that as one of the key features. Auth is generally hard to do, so we've been working very hard to kind of simplify that. So if one of the questions I often get asked is how do you kind of fit all of these pieces together? What is the model? How should I sort of think about the offering from AWS? So first of all, we start with the platforms that we support. We support the main platforms we support are iOS and Android native, web development for your JavaScript-based apps, including PWAs, and React Native as well. Then we have three pillars to our offering. The first one is the Amplify framework. It's an open source framework which has libraries, a CLI toolchain, and the UI components. So kind of think about it as a set of tools that you install on your local machine which enable you to build your app. The second piece of it is integration with the back-end cloud services. I've mentioned three here, Cognito, AppSync, and Pinpoint, which is basically the auth, the data, and the analytics. Most apps want this. Most apps need this. We support a number of other services as well, straight out of the box, and I'll talk about some of those. And the third leg of this is developer tools for the CI/CD piece that I talked about earlier. Deploying and testing apps is important for all developers, and we've been making and delivering tooling in this space. So I want to look at each of these three in a little bit more detail, and I'm going to start with Amplify framework. And the first piece of the framework that I mentioned is the library. We have focused on front-end developer needs, and what that means is we started with a pretty opinionated implementation of what the back end should look like, so that front-end developers who are not familiar with AWS services can really just kind of plug and play and start learning and going fast. We're supporting native app development with our Android and iOS SDKs. We also support JavaScript development across a number of frameworks. And as I said, the approach we've taken is category-based. It's an opinionated implementation of auth and analytics, and also some more experiential services like XR and interactions, which is the Lex service, the chatbots. And for those developers who want to do more, we have escape hatches for all AWS services. So basically, you can use any AWS service in any way that you choose to, and mix and match with some of these more opinionated implementations. The second piece of this is UI components. We have drop-in UI for things like auth, sign in, sign up, photo picker, chatbots, and a few other things. And then the third piece is the CLI. And the CLI is there not only for integrating the back-end services with a few simple commands, and we'll show you some of that a little bit later in this session, but the CLI also has a very rich code and type generation capability for GraphQL. And this can be used throughout the app lifecycle in an iterative way to kind of minimize the amount of configuration and back-end work you need to do in order to implement a GraphQL back-end. So we're gonna dive a little bit deeper into that. Just a few things about the code gen which are interesting. First of all, it allows you to map your database types to your app code. Again, fully automated. You can focus on your use cases rather than trying to figure out how the wiring works. We also enforce a strong contract across the app code, the API, and the database. And we enable developers to quickly prototype and integrate those into the app. OK, so this is just a quick example. So here you can see the only thing that developers really need to do is run the Amplify add API command, edit and push the schema, and you can see the GraphQL schema here on the left-hand side. And then the CLI will generate the backend, including the database, and the client types are generated, and you get the skeleton code you see on the right-hand side, so you can get straight to writing your code. And I guess for the iOS developers in the room, you'll recognize that to be a Swift code gen. So that's what we've got in the CLI up until about a week or so ago. What I want to talk about now is what we launched on Sunday, multi-environments and team workflow. This was one of the biggest requirements that we've heard from the community, that the CLI is super powerful, but we want to be able to work with multiple environments like dev, test, and prod. We want to have multiple users and teams working together on the same code with different backends or the same backends. And so we've just launched the multi-environment and team workflow feature. It's basically built on Git, so it uses Git-style interactions and project switching, and you can use it to share between team members. This is all done in open source, so for those of you who are interested in how it works, or if you want to give us feedback, or you want to contribute on GitHub, it's, we work in a completely open source model, so we welcome all contributions to this. So the second piece of this is the cloud services, and I want to kind of focus on kind of two buckets of cloud services. First, what I'm going to call the core services. So we have auth, data, and analytics. Data is the main piece of that, which is the AppSync product that we have. And as you can see, AppSync is not a encapsulated database offering. Underneath AppSync are all of these different databases, data sources, which AppSync can integrate for you. So there's a huge amount of flexibility in what you can do with AppSync, and you can use everything from DynamoDB through Elasticsearch and a couple of other things we're going to talk about in a while. And then the second part of this is a set of experiences which you can build straight into your app. I mentioned AR/VR, I mentioned Lex and interactions. You can also build PubSub and simple things like storage, retrieval, file and storage and retrieval. So I wanted to spend a little bit of time to talk about the data piece of this. We launched AppSync 12 months ago. It's a real-time and offline data service built with GraphQL. I'll come on to the GraphQL piece in a second, but I really want to kind of focus on why AppSync is important, what it does for you. So the first feature of AppSync is it's a real-time collaboration at scale. I kind of mentioned that there are all kinds of different backends like DynamoDB, so you can operate at scale with Dynamo and the normal kind of AWS scale. And AppSync builds on top of that to provide real-time collaboration, and we're going to show an example of a customer who's actually built something with this feature in mind. The second piece is offline support. We've done a whole bunch of work on working with mobile devices that, as you all know, can go off and online, and we need to keep the data in sync. We need to be able to work with the data offline. We need to be able to resolve conflicts and so on. So AppSync is taking care of that. We already talked about the multiple data sources. We have right now Elasticsearch, DynamoDB, HTTP data sources for your legacy data, and you can build your own using Lambda, so you can wire up Lambda as well. And finally, fine-grained access control. So we've integrated auth directly into this service so that you can manage data at a very fine level, and who can have access to that data and what they can do with that data. So you can decide how you want to manage the security of your data. The other piece of this is the GraphQL. And one of the questions that we often get asked is, why did you pick GraphQL? Why was GraphQL an important part of your design decision? And there are a number of reasons why GraphQL is better for the way that people build apps. I think most of you have dug into it, so a lot of this should be familiar. The data aggregation and data selection allows you to consolidate multiple backends into a single API. It allows you to define exactly what data you need, so there's no need for overfetching or underfetching of data. And when you combine those things, you end up with bandwidth optimization as well. The other areas are a little bit kind of more interesting, I guess, from a development point of view. First of all, the rapid prototyping. This enables both client and server teams to iterate independently because you've got the strong contract provided by GraphQL. And the second piece of this is around evolving your APIs and changing the API over time. So it's easier when you can kind of start small and grow your API over time without disrupting how the back end is working. With that, I want to talk about the new features we launched last week. So AppSync now enables pipeline resolvers. Previously, if you wanted to stitch together more than one API or kind of do any kind of orchestration, you would have to do it in a Lambda function at the back end or orchestrate on the client side. That's a lot of bespoke code. It's not necessarily the most scalable and probably not the most secure. So what we've done now is we've given native support for pipeline resolvers. So that's a big feature in the service. The second feature is Delta Sync. This is actually a client-side feature that we've built into the library. Previously, you had to essentially, when you went offline and came back online again, if the data on the server had changed, essentially the whole table was pulled down onto the device, and that was a performance issue, especially if the table was large. So with Delta Sync, we look at individual rows that have changed in the data and only bring those rows back. And finally, the third feature is that with the launch of Aurora Serverless as a data API, which happened last week, we also launched support for Aurora Serverless. So for all of those who want to use AppSync with RDS, this option is available. Please note that it's beta, and we will be keeping up with Aurora as they go out to GA. Okay, with that, I want to talk a little bit about customers and what customers are doing with this. So this one is actually quite interesting. Sony has built a companion robot, AI-enabled companion robot. 20,000 of these have already been shipped in Japan, and this is coming to the US, so you guys should definitely check this out. This is built on serverless and IoT, and also AI services, and several others that AWS offers. I'm not sure you can make out that architecture picture, but it's a bunch of AWS services there. They're using AppSync in this situation, in this app, for synchronizing the local data that's collected by the robot back to the cloud and ensuring that they can analyze it back in the cloud. So this is all about data sync, one of the key features of AppSync. For those of you who want to check that out, there are some sessions on Thursday still where you can go and learn more about that. The second customer case is CookPad TV. Again, these guys have a somewhat different use case. So this is a live TV show where customers can interact. I don't think you can make it out, but on the top left, the picture actually shows how many clients are connected. There's 25,000 connected clients, all chatting and sending likes and dislikes and all this sort of social interaction. All of that fan out to 25,000 users, all of the subscriptions, the real-time updates, that's all happening with the support of AppSync. Okay. The third pillar of our offering is around developer tools. And for those of you who are familiar with this, we've had a service for a while now called Device Farm. This enables developers to test their apps, whether they're iOS, Android apps, or web apps, using the latest devices. These are real devices that we host in the cloud, and you can test your app either in parallel in an automated fashion, so you can test on multiple devices in parallel. You can also interact with these devices through the browser or a local client app with gestures and swipes and so on, so you can have remote access to these devices. And also, we've integrated with your preferred IDEs, such as Xcode and Android Studio, where you can essentially integrate with those devices as if they were locally connected to your development machine. So it's a great tool for improving the quality of your apps. And finally, what we've just added is the AWS Amplify console. We launched this on Sunday. This is a new service for building and deploying static web apps with serverless backends. So all of those CLI features that you saw earlier, where you could generate your backend and integrate that with your app, this service will essentially take that, build your front end, deploy your back end, and also then host it in the cloud. So you essentially have got a web app hosted in the cloud. This is great if you're doing blogs or static web pages. Also good if you're doing serverless web apps, and also particularly good if you're doing things like progressive web apps. And this is built on top of CloudFront and S3 with a whole bunch of features added on, things like custom domain setup, continuous workflows. It's built on top of GitHub, so essentially you can use the branching in GitHub to have multiple environments that you could host in parallel and work, your dev, prod, and any stages basically that you wanted to have. We've also implemented atomic deployments so that you can essentially have a green-blue type of deployment scenario where you can quickly switch your hosted app or page from version 1 to version 2. So this is a great new service. Go and check it out if you've got time. And with that, what I want to do is to quickly conclude on, again, how is this all held together? The three pieces of this are all held together with the CLI toolchain. The CLI supports CodeGen with the framework. The CLI supports the configuration and management of the cloud services. And the CLI supports the CI/CD team workflows and multi-environment support in the developer tools. So that combination is essentially kind of a holistic, integrated developer experience for mobile and web development. You're going to learn more about that in a few minutes when Michael comes up to show some of these features in action. But before I do that, I want to invite Tom Bray onto the stage. Tom is the chief architect for Ticketmaster, and he's going to tell you about their use case and what they're doing with AppSync and GraphQL.
Awesome. Thanks, Amit. Hello, everyone. Thank you for joining us today. My name's Tom Bray. And one of the things that I love about my job at Ticketmaster is that I get to help teams adopt disruptive technologies. We're always looking for ways to reduce complexity so that our engineers can spend less time wrestling with complexity and spend more time focused on building amazing experiences for our fans and for our clients. To give you a few examples of that, we use React Native to simplify mobile development. We use Next.js to simplify web development. But most importantly, we are adopting GraphQL across the board. So today I'd like to tell you a little bit about our GraphQL journey and how AppSync helps us solve some of the challenges that we've faced along the way. So I'll start with why, and I'll talk a little bit about our GraphQL vision. I'll talk about where we started and some of the problems that we wanted to solve with GraphQL, and I'll talk a little bit about our strategy for how we plan to achieve our GraphQL vision. So let's start with why. So I'd like you to imagine the future through the eyes of this persona. Her name is Sarah Connor. She's a rock star React developer for a living. She's also an avid musical theater fan. And her primary objective today is to buy Aladdin tickets. Now, theater productions are long-running shows. There are multiple shows each week. So for Sarah, it's less important about what date she attends the show, and it's more important that she finds the right seats for the right price. So what she really needs is an experience where she can shop for seats across dates and compare all in one place. And that's exactly what we have here on the screen. So there's a date slider along the bottom that she can quickly navigate through all the dates for the entire run of the show. She can tap on each individual date and instantly update the seat map with all the availability for that date, and she has pricing information there as well. So she has all the information she needs to be able to make her purchase decision. So, well, and of course it's blazing fast. So she's a React developer, so she's curious how we built this. So she decides to look under the hood, and she realizes that we're using GraphQL to build this. And in fact, we're making one request, one GraphQL query, to fetch all of the data we need in the shape that we need it, in a tiny payload. So just to zoom out and capture a little bit, give you a little bit of perspective of why this is so important for us, We do approximately 100,000 events a year, so we're working with a massive amount of data, and we need to deliver that data efficiently to a massive number of people. So anytime we can reduce the number of requests that it takes for a user to achieve their objective, that's a big win for us. So let's get back to Sarah's story. She has now decided she's going to select the seats that she wants to buy. While she was looking under the hood, she noticed that we're using GraphQL subscriptions. So we're subscribing to the availability of seats for these events. So she wants to see this in action, so she fires up 2 browser windows, and on the left she selects the seats that she wants and reserves them, and on the right-hand side we see those seats disappear. So being able to push availability data instead of polling for it is a game changer, especially when you consider the fact that we're selling 500 million tickets a year. So the data that changes the most in our system is availability. So if we zoom out a little bit, our GraphQL vision is to have a single comprehensive GraphQL API that represents the entire fan experience from beginning to end. So that's finding events, that's shopping for seats, that's purchasing tickets, transferring, selling, and attending the events. And the reason this is important is we want Sarah to come and work for us, and we want her onboarding experience and her everyday experience to have as little complexity as possible. So on her first day, we want her to be able to sit down and fire up her GraphQL query editor and just start typing and realize that she has all of our data at her fingertips with autocomplete. She doesn't have to dig around in Swagger documentation. She has it all right there. So she has this sort of the same experience that the consumer would have of being able to have all of the information she needs to be productive. When I talk about the business value of GraphQL, I talk about the opportunity cost of complexity. Every minute a developer spends wrestling with complexity is a minute she could have spent creating something awesome. So that's why GraphQL. Let's talk a little bit about where we started. Overfetching, underfetching, and client-side complexity. So what you see on the right is the response from a REST API. The endpoint allows you to fetch metadata about a live event. So this response that you see here represents all the metadata for one event. If you look at the experience on the left, that circle there around Saturday, March 31st, all we need from that response is the start date of that event. And we need that for 200 events to be able to render that date slider. So that's overfetching. We need one field, and we're getting a lot more than that. We're also underfetching because we need pricing information, we need availability data, and that's not part of this response. We need to hit different APIs, different endpoints to fetch that data. Now, if we were to do all the aggregation and transformation of that data on the client, we're introducing a lot of complexity. And we have to replicate that complexity across iOS, Android, and the web. What teams typically do in this scenario is they take that aggregation and transformation logic and they move it to what's called a BFF, a backend for your front end. Okay, so you're adding a new component to your infrastructure. This thing provides a bespoke API for your client of choice, and it does the heavy lifting of reaching out to those upstream, upstream REST service and transforming that payload, that large payload, into something fit for purpose. Teams also use this approach to aggregate data from multiple sources and transform it to send to the client. But what's happening here is that we're introducing more complexity. We've added another point of failure. We've added another thing that we need to maintain and operate at scale. And there's a better way to do this. We are incrementally replacing our BFFs with AppSync. We're incrementally getting rid of our REST APIs and replacing them with AppSync. And dramatically, over time, we'll dramatically simplify our architecture and have one place where we can perform aggregation and transformation. And we can deliver just the data you need in a single request. All right, so let's talk a little bit about how we're going to achieve this. So we're essentially marketing a disruptive technology to internal customers. So we can borrow some learnings from the marketing community. So I'm sure you've all seen this curve, the tech adoption curve. It's divided up into market segments, innovators, early adopters, the early majority, et cetera. Each of these market segments have different motivations, and it's helpful to understand their motivations to be able to help define your strategy for adopting technologies. But that curve isn't actually smooth in the real world. There are gaps in it. And with GraphQL, I would argue that there are two gaps. There's a small one between the innovators and the early adopters, and there's a large one between the early adopters and the early majority. And we need to figure out how to bridge those gaps so that we can achieve our GraphQL vision of widespread adoption of GraphQL at Ticketmaster. So the innovators see the value of GraphQL right away. They're off to the races. They're building GraphQL APIs, which is great. But what you're going to end up with is a lot of GraphQL APIs instead of one single comprehensive API. That's a challenge that we'll have to unwind over time, but I encourage those teams to start the learning process that way. But when we get to the early adopters, they're looking for a strategic leap forward. So they're really attracted to GraphQL for the performance. Being able to fetch the data you need in a single request is a big deal. Being able to push data via GraphQL subscriptions is important. So they're intrigued by that. But they're also the folks who they want to figure out how to actually deploy GraphQL in production. So they have real-world questions. They want to know how to solve the N+1 problem. What about caching? How do we support WebSockets at scale? So bridging this gap, we need a solution, we need an answer for all of these things. And that's where AppSync really comes in and plays a major role here. All of these questions are answered by AppSync, especially when you think about WebSockets, terminating WebSockets. Being able to use a managed service for that instead of taking on the burden of building that infrastructure ourselves is a huge win. So let's talk about the early majority. So these folks are pragmatists, and they are looking for an increase in productivity. So does GraphQL make them more productive? Well, it really depends on what we're asking them to do. If we're saying, hey, I want you to rewrite all of your REST APIs in GraphQL, then no. That's more work for them. So what is it that we really want them to do? And I would argue what we want them to do is to stop thinking about building APIs and start thinking about building functions. So to illustrate what I mean, here's an example GraphQL query. We have event metadata, we have availability, we have pricing information. And traditionally, all of this information has been provided by 3 different teams who haven't had to work together before. They have their own APIs, and they're able to work independently. So what we're asking them to do now is to contribute functions, resolver functions, to help resolve this query. But we need them to collaborate to do that. So what does the collaboration model look like? So I think there's 2 different flavors, really. On the left, I have what we call the monolithic API. So this is the idea where you take your GraphQL query engine, your GraphQL schema, and all of your resolver functions, and you bundle them together in a single deployment artifact, and all of the teams are working in the same code base and coordinating releases together. And that works okay for small teams who are all using the same language, but it really starts to break down in a polyglot environment where you have a lot of teams like we have at Ticketmaster. On the right, we have the AppSync and serverless model. So in this case, the GraphQL query engine is a managed service, so we don't have to worry about that at all. And we can deploy our schema and our resolvers independently, and we can even use AWS Lambda as a data source. So all of these teams in a polyglot environment can use the language of their choice for those Lambdas and be able to contribute to this effort without stepping on each other's toes. But what we really want the early majority to do is to adopt an event-driven serverless mindset. So if we take a look at this simplified architecture diagram, We've got a Kinesis stream, triggers a Lambda. The Lambda triggers a mutation, and that fires a GraphQL subscription that updates our real-time seat map. Now, so that's an event-driven architecture, and as teams adopt that mindset and start thinking about their problems in an event-driven model, AppSync becomes an obvious choice. For example, if you were to remove AppSync from this picture, what would you put in its place? You'd have to roll your own solution there, and we would much rather use a managed service in those cases so that our teams can focus and be productive and focus on building amazing experiences for our fans and our clients. So before I leave you, I just want to give you one pro tip. As you start to learn about AppSync and real-time data, most of the examples you'll see are about Dynamo and Elasticsearch, which works out of the box with subscriptions. But there is also something called a local resolver. And that essentially allows you to turn anything into a real-time data source. And that's what we use here. That's how we're powering that real-time seat map. So with that, thank you. Please follow me on Twitter at Tom Bray, and now I'll turn it over to Michael.
Hey, so my name is Michael Paris. I'm an engineer on the AppSync team, and I've more recently been working a lot on Amplify, specifically around the GraphQL support from what Amit showed you, that GraphQL add API command. What I'm here to do is I'm going to show you some of the things that we've been talking about. So what we're going to do today is I'm going to show you how I built this application that I'm calling ChatQL. It's a pretty simple React application. It's real time. It allows you to have multiple users. It's basically a group chat app. You sign in. Here you're seeing I'm logging in through a Cognito user pool. I'm then logging in as my little brother, Zach. And as I log in, you're going to see those names appear. And I'm going to start a conversation between Michael and Zach. You saw on the left window that was streamed in real time. And then I'm just going to start typing. So it's a pretty simple chat application. But we're going to step through basically how I built it from scratch using both AppSync, Amplify, the framework, the Amplify libraries, and the Amplify CLI. So when you're going to start building a new web app, the first thing is kind of think about what do you need. So pretty much every application is going to need user management and authorization. In this application, we're going to need real-time APIs. We're going to need client SDK support and tooling that we can use from our development environment to connect to those services. And we're also going to need to think about our deployment and our operations. So that means we need to have multiple environments. We're always working on a team, so multiple users need to be able to interact with the same code base. You're going to need hosting, so this website has to be somewhere so that our users and customers can go and access it. We're going to need continuous integration and deployment so that as I make changes to my code, I can push it into Git. That's going to start a build, and then that build's going to flow through to my test and production environments. And we're going to need analytics so that once it's running, we want to know how our application's being used. We want to know our session times, how many people are viewing it, what are our customers interacting with most, and we're going to talk about that as well. So how do we get there? We're going to use a lot of AWS services. So the first one is Amazon Cognito User Pools. This is going to serve as our user pool and be basically our registry for users, as well as providing authentication credentials that we can use to access the cloud services in our API. We're going to need the real-time API, which is going to be served through AWS AppSync. We're going to need the client SDKs and tooling, which is the Amplify framework. The multiple environments is going to be supported by the Amplify CLI. Hosting and CI/CD will be through a new product that we released last week called the Amplify Console. And analytics, which is going to be provided through Amazon Pinpoint. So as we mentioned, the Amplify CLI is kind of here to tie everything together. And one of the main things that it does for us is it allows us to really easily and quickly scaffold out projects such that we have the services that we need without having to worry too much about the fine-tuning until we need to. So here you can see a sample of how you might do this. This is what you would type in a new terminal window in order to get started really quickly with the Amplify CLI. The first thing you do is run amplify init. This basically sets up your project. It'll create a directory in your project called Amplify. That'll have some special things in it that make it easy to control the multiple environments and add new services. Next, we're going to run Amplify add auth. This is going to create a user pool with best practices cooked in. We're next going to add analytics. This is going to create a pinpoint project that we can use to store analytics about our client React application. And then we're going to add an API. And this is where things get really interesting. But this is going to create an API as well as create all of the data infrastructure that lives behind the API so we can get started quickly. Next, we'll run Amplify push. Amplify push basically compiles your project into a set of CloudFormation documents, and then all of your resources are deployed through AWS CloudFormation so that you can reliably reproduce environments. So here's my terminal. This is me using Create React App, which is a popular CLI tool that's not published by AWS, but is popular to create new React applications that are ready to be used. It'll even help you start with PWAs if you so choose. So what this is doing is it's going to install some basic libraries into a new package for me. It's going to say happy hacking, and then we're ready to go. The next thing I'm going to do is I'm going to initialize that Amplify project. You can see here I'm just going to type amplify init. This is going to go ahead and create that Amplify directory in your project, which is going to hold all of the CloudFormation resources and any other things that you need in order to keep track of the multiple environments. It's going to ask me some cool questions. It's going to ask me for a name for an environment. I'm going to name this Sandbox because this is my local development environment. I don't necessarily want this to go to test or prod yet. It's going to ask me what my code editor of choice is, what language I'm writing in. It actually already knows that I'm building a React application because it detected that I had React assets in my package. And then what it's going to do is deploy a root stack to CloudFormation that's going to serve as the entry point to our application. And we're basically going to use CloudFormation nested stacks in order to manipulate the rest of our resources. The next thing I'm going to do is run Amplify add auth. So this, like I mentioned, is going to create the Amazon Cognito user pool. This is a really great and quick way to add user authentication and user management to any application, whether it be a web app or a mobile app or something else we haven't thought of. So here it's going to ask for if I want to use a default configuration. I'm going to say yes because it comes with some smart defaults baked in. It's going to use email as your primary mode of authorizing your users and authenticating your users. And then with that, it's ready to go. The next thing I'm going to do is add analytics. So this is what's going to add the Amazon Pinpoint project. This is going to serve as an endpoint that I can use to stream analytics from my React application into the cloud, and then you can see things like session time and how many views you're getting and different click events that you've instrumented your app for. It'll also help you chisel down demographics of your users, and then you can target them with mobile push and notifications. I'm again going to use the smart defaults and then just keep going. And that's ready to go. The third thing I'm going to do is I'm going to add the API. And I'm going to go off on a tangent for a second because there's actually a lot that's going on here. But here you'll see I'll type amplify add API. It's going to ask me if I'd like to use a GraphQL API, but we also support API Gateway if you would like to use a REST API. Here we go. Select GraphQL. I'm going to give it a name just for my API. It's going to ask me how I'd like to authenticate that API. I added auth. I'm using the user pool, so I'm going to tell it to use a user pool. And then it's going to ask me if I have a schema. So in this case, I did have a schema. It was already there, and we're going to look at it in a second. But what I want to draw attention to is that the nice part about this utility is that it's going to let us think about our application's data model kind of at a high level without worrying about all of the details of how it works underneath. So what does that mean? Basically, we're going to use this new tool called the GraphQL transform that was also open sourced alongside the Amplify toolchain and the Amplify CLI. And what it does for us is it allows us to declaratively define our data models using the GraphQL schema definition language, which is SDL for short. And then that GraphQL schema language is going to get compiled into the CloudFormation document that implements that data model. We're using GraphQL directives to power this, and the way that it works, and it's an open source project, so you guys could contribute and build your own what we're calling transformers. But the way that it works is we've defined a few directives, which are basically a JavaScript class in the open source project, that whenever we see a certain directive, it'll do some amount of manipulation into a context that allows us to manipulate how that CloudFormation document comes out so that you can have a really simple interface. So I mentioned that it allows you to declaratively define data models. And this is important because I don't want you guys thinking necessarily at the beginning of a project about how your Dynamo tables are going to fit together, what indexes do you need, what are your query patterns. Instead, it'd be nice to be able to think at a higher level that in this case, we have users, there are conversations, and there are messages. We have some kind of high-level knowledge of how these things relate to one another. So a user can have many conversations, and a conversation can have many users. So that's a many-to-many relationship. In this case, we're using two one-to-manys in order to implement that many-to-many. And then we also have messages, where conversations have many messages. And then me as a user, I write messages, so I have ownership over some of those messages, and therefore I have many messages. So this, at a high level, is kind of what you're thinking when you're starting this project. And then the way that you actually implement this using Amplify and AppSync in the GraphQL transform is with a single schema.graphql file that's been marked up with these special directives. So here's the actual schema for our ChatQL application. And you can see a couple things. First, you see type user. You see that @model directive. @model essentially means store this information in a DynamoDB table and then auto-generate some operations that allow me to operate on that data model. In this case, you can see I turn them off for some. You can see message. I'm turning subscriptions off and queries off because all we want to do is be able to create those messages. And then we'll actually query those messages through related fields that we'll look at later. And then you can also see that there's an auth directive. The auth directive in the Amplify or GraphQL transform and with Amplify basically means that we're going to code generate AppSync resolver code that implements common use cases that mobile app and web app developers see every day. So what this means now is we have basic ownership authorization, where I can say I should only be able to access this object if I am the owner. If I was the one that created it, and I should not be able to read it otherwise or update it otherwise. This would be common for like a user model. You wouldn't want other users deleting your user object, so you can use the ownership authorization directive to do that. There's also group authorization that's both static groups, so you can say something like any admin user that's a part of the special admin group can basically have full access to an object. Or you can do what we're calling dynamic group authorization, where every object in your database will actually store what groups can access that particular object, and then that authorization check is performed on a per object basis. So here I'm now going to go, so that was my schema. That was right after I ran Amplify add API. I'm now just going to run Amplify push, and what we're going to see is that that's going to start pushing that CloudFormation document into AWS, and then we're just going to see a stream of all the things that are coming back. You can also see you've been given an opportunity to use the CodeGen utility. This application was written in plain JavaScript, so we're not using it, but if you were building an iOS or Android application, you'd be able to create native types for your application right there. And then here you can see it's going to start creating some things. And to keep in mind, we did not have to worry about what these particular assets were, what these resources were, all the fine-tuning of it. You can see it all in the CloudFormation document when you get to the point that you need to start being a little bit pickier about how you set these things up, but it's all kind of been set up for us with best practices in mind. So I'm just going to skip ahead because we'll look at it again. So what was just created? After that API was pushed to the cloud, there were a few things. We created an AppSync API. We created 4 AppSync data sources, which you can think of as a container that allows us to talk to databases on your behalf using IAM roles. We created 20 AppSync resolvers without you guys even having to think about it. There were create, update, delete, list, get, also connection fields so that I could implement the join between a user and messages, for example, or between the conversation and messages. We added 6 scoped down AWS Identity Access Management roles. So this is one that we were able to determine what is the least access we can give to this role so that it's safe and we're not over-prescribing. We then created the Pinpoint project, the Cognito user pool, and the Cognito identity pool so that we can access objects in S3 using IAM while still authenticating with our API using user pools. So what can we do with it? So that sounds great, but let's look at kind of what the interaction model is now. So just with that setup that I showed you and nothing more, we're able to list users. This is just a GraphQL query that you'd have access to. It has pagination baked in. You can give it a next token to kind of move through sets. You can get a user and their conversations. So in the schema, this was implemented as an @connection directive. That allows us to associate objects between 2 DynamoDB tables transparently which basically adds relational capabilities to NoSQL data stores. We were able to get a conversation and its messages. So this is what would fill that chat view pane in the main application that we built. And this is just similar to the other. It was implemented with a connection directive. And once we get the conversation, we can get all the messages that are corresponding to that conversation. Under the hood, what's happening is we actually went and provisioned a DynamoDB global secondary index such that we can efficiently query the messages table to find all the messages for a particular conversation. We can also subscribe to new messages in conversations. So this is how you would implement a subscription query using AppSync. Here I'm saying I want to subscribe to the onCreate message. So every time a message is created, I want to get the message as long as it's the same conversation that I asked for. So here I'd say give me all the messages for conversation 1, and then this would only yield results if that message was indeed attached to that conversation, which again was implemented through that @connection directive. We can create conversations. We can create messages, and we can add users to conversations in the many-to-many relationship. So now we've got our backend set up. It's been deployed in my local environment, and it's time to build our application. So here's where the Amplify library comes in. The first thing you do is you're going to configure the library. So when you ran Amplify push, it's actually going to create a file called aws-exports.json that's going to have all your project config in one place. You can just import that file, run Amplify configure, and now Amplify is ready to talk to your backend. In the application, you saw when I logged in that the login window where I was filling in my username and password, doing sign up, I gave it my MFA code that came through my email. I did not build any of that. I just put these 4 lines in my application that came straight from the Amplify library's components that are specifically suited this. In this case, it's React, but like we mentioned, we have support for Ionic and Angular and other platforms. Then we got to the point that we needed to fill data. We needed to get the data from our backend, and we needed to provide it to our application's front end. For that, we're going to use the Amplify Connect component. This, again, I imported from the Amplify library. I then can give it a query. I can give it a subscription query that will subscribe to updates that are relevant to this query. And then I just give it a quick function on how to merge those new messages into the query that I first ran. And then from there, I get some nice helpers like loading and error, so I can know if it's an error, I can easily show an error. If it's loading, I can show a loading spinner. And if the data is ready, I can actually render my view. So we didn't have to do any extra work for this. It's just going to work out of the box. And you can see here that I'm calling my getCombo query that I showed earlier, and I'm using that onCreate message subscription, which we saw earlier as well. And here's how you hook it up. The last piece is how do you mutate objects. So this is an example of how you would use the Amplify library in order to create a message. Now, when I call this create message mutation from the API category of Amplify, it's actually going to automatically trigger that subscription because AppSync's doubling as our pub sub broker, and you get that out of the box. The last piece is to instrument analytics. So this is using the Amplify support for the analytics category. This is going to just a simple, no-nonsense way of instrumenting your application with analytics that you care about. In this case, I'm using the component did mount lifecycle method in React and the window add event listener method in order to calculate the session load or the session time for that particular user visit. So here you can see our application again. This is now running on localhost. This is on my computer. I haven't deployed it anywhere. The backend's in the cloud, but the front end's running through. I just ran npm run start, and I've got the application running. You can see I'll be able to log in, and the same thing's going to happen again. Just show you that the chat's still working. So here you can see it's going to be streamed. I'll click Michael there. That conversation appeared in the bottom left window, and then here we're going to be able to start talking. So now we've gotten to the point that we've got our application working locally. We now want to start thinking, how do we get this thing into production, and how do we have multiple environments? So this is a new feature that came with the Amplify CLI that allows you to run multiple environments using Git, which is nice because it ties into your existing developer workflow. So here, when I started, if you remember, I started an environment called Sandbox. What I'm going to do is I'm just going to add all of my code to my Git repo. I'm going to make an initial commit. That's going to add some files. I'm then going to push that into GitHub in my master branch. The next thing I'm going to do is I'm just going to branch and create a dev branch. So what you're not going to see on the screen is I actually went behind the scenes and I changed the word sandbox in the top left of the page to say development in my dev branch. And then you'll see I'll branch again for my production branch. And I'm just going to change that one word to say production just to show you how that works. So I'm going to start 2 branches. And then I'm going to check out those branches. I'm going to make that one change. And then I'm going to push that to my GitHub and have now 3 branches in my GitHub. So I'm going to skip ahead. After we've deployed to GitHub, we're going to deploy our application to the cloud. So when I say deploy the application, I mean the whole thing, the back end, the front end, and I want to see it happen as soon as I run a git push. So how do we do that? This is where the new Amplify console comes in. So this is a streamlined experience for CI/CD and hosting, web hosting for web apps on AWS. So I'm going to connect my GitHub. That's actually using GitHub OAuth. It's then going to start listing all my repositories. And all I'm going to do is select the repository that I want to deploy. So in this case, GraphQL React. And I'm going to select a branch that I'd like to deploy as well. I'm first going to do the dev branch. And then later, you'll see we'll do the prod branch. So what's happening now is Amplify is going to configure basically a build environment for us. It's got a build spec. That's what that file is. And I'm going to give it a service role that gives Amplify permission to touch resources in my AWS account so that it can actually do the deployment. And push my backend through CloudFormation in my account. So as soon as this is going, it's going to start a build. So you'll see it'll just take a second. But this is going to go. It's going to provision a container that can actually run my build. It's then going to run through that build spec where I can add my own individual testing steps. It'll even call out to CloudWatch events so that I can add custom Lambda functions that might do some sort of more complex integration testing. And then here you'll see I'm going to actually add the production branch as well. And then we'll watch as that build step works. So here I'm just adding the production branch. We're now going to have 2 environments that are managed by the Amplify console. And that's going to be dev and prod. Save and deploy that one as well. So here you see our project view. The top, you can see the dev environment. The bottom, you can see the prod environment. You can see that we're currently in the provisioning step. That'll take just a few minutes. And then it'll move from provision into build, into deploy, and then into verify. You can see that the provision, you get nice logging. So all of the operations that are happening on the container that we're managing on your behalf, you can get insight into actually what's happening behind the scenes. And then this will just go. You'll see provision finishes. It'll then get into build, where it's actually running an Amplify build, which is going to build both my backend, but it's also going to build a production version of my front-end React application. And it's going to take those production assets, push it to S3, and then deploy that through a CloudFront CDN. And then the trick of the atomic swapping is a nice add that uses Lambda add edge. So here you can see it cloned my repo. It then built my backend. It then built my front end. It deployed it to S3. It swapped using the atomic deployment, and then it continued going. So once that's ready, I just want to show you what it looks like from the end product. So now we've got our dev and our prod branches again. This is the same view you saw. In the verify step, it's actually using a headless browser to it'll actually go read the page from your deployment, and it'll show you what your website looks like on multiple different form factors out of the box. So it'll show me what it looks like on an iPhone, on an Android phone, on a tablet, on a desktop, and you can kind of just get going that way. And then here you can see in the top left, we've got GraphQL in development. That's because this is the development branch that's actually been deployed and pushed to the cloud from the Amplify console. Here it's going to send me my MFA code again. I'm going to go ahead and log in. And then we're going to get that same experience that we had from the beginning. And here's me chatting again with my brother in production. So I saw dev. We're now seeing production. And then we're just going to have chat conversation back and forth. So what's really nice about this is that this took me about 15 minutes to do. We did not have to think about DynamoDB tables. We did not have to think about global secondary indexes. We didn't have to think about how those things kind of interrelate. Especially, you didn't have to go read any documentation to figure that out. We just had that really simple schema file. And then at the point that you need to get more fine-tuned, we give you complete access to do so via safety hatches because it's all through CloudFormation. So if you need to take something and tweak it a little bit, that's totally your prerogative to do so. So to close, just want to I hope that showed you a little bit about how the Amplify toolchain fits together, how we were able to use the Amplify library and framework components in order to connect the cloud components to our front-end application, how we were able to provision those cloud services really quickly using the Amplify CLI, and then the developer tools of the CI/CD pipeline that came out of the box with the Amplify console, and then just deployed it into production. And now every time I make a change to that repo, I'm going to do a git push. It's going to make that change, and we're going to see that flow through to production right away. So that's all we had for you. I really hope you enjoyed the talk. Thanks for listening. And then please fill out the session or the survey at the end of the day. If you have more questions, we have more sessions tomorrow. There's MOB202-L where I'll be giving a more in-depth conversation about how I built that ChatQL, but a live demo. And also MOB310, where they took a version of that ChatQL and then moved it and added AI services as well as offline support. That's a really cool demo that I would recommend checking out as well. Thanks, and have a great day.